Okay, let's look at another example. Call this example 2. So in this example, we want to find and classify the critical points, places where the derivative is 0, of the function g of x equals 1 plus 4x cubed minus x to the 4th. Okay, so the first thing we're going to do is take the derivative of g. We'll get 0 plus 12x squared minus 4x cubed. Let's factor this so we can find its zeros. We'll factor out 4x squared. We'll get 3 minus x. So the zeros are x equals 0 and x equals 3. Those are the two places where the derivative is 0. Okay, so now we're going to test points on either side of 0 and 3. So our test points are going to be any point before 0. Let's do -1, which results in 4 times -1 squared times 3 minus -1. What is that? 3 plus 1 is 4. So 4 times 4, which is 16, which is positive. And then we'll test a point after 0 but before 3. So 1. Put 1 into the derivative. We'll get 4 times 2, which is 8, also positive. And then we'll test a point after 3. Let's put in 4. So we get 4 times 4 squared, 3 minus 4, which is 64 times -1, -64, that's negative. Okay, so now we can draw a sign diagram. So we have 0 and 3. So before 0, it's positive. After 0, it's also positive. And then after 3, it's negative. So 0, f of 0, is a horizontal point of inflection because the derivative does not change sign across 0. It's positive before, so looks like this. It's positive slope, and then it gets to 0 slope, and then it's positive slope again. So it's a horizontal point of inflection. Looks like that. The graph looks like that. And then at 3, f of 3, we have a local or relative maximum. It's positive before, goes to 0. Slope is positive before, it goes to 0, and then negative afterwards. All right, let's do one more example. Call this example 3. Let's consider the graph of the derivative. And then we'll do two things. One, we'll find the intervals. Find the intervals where the function is increasing. The function f of x is increasing / decreasing. And then 2, we'll identify any relative extrema. Or horizontal points of inflection. All right, so here's the graph of the derivative. Note, this is the derivative, not the function itself. The derivative goes up, comes down, and then goes back up. Okay, so let's do part A. So we want to find the intervals where the function f of x is increasing. So f of x is increasing where the derivative is positive. Okay, so this derivative f prime is positive here all the way to 4, and then from 4 onwards. So all those outputs are positive. This is the positive output region. Okay, so f of x is increasing on the interval 1 to 4 and the interval 4 to infinity. It's decreasing when its outputs are negative, so these are the negative outputs here, negative y values, and that's before 1. So f of x is decreasing on the interval negative infinity to 1. Okay, and then part B, you'll notice at 1 here, at 1, the derivative goes from negative to positive. So f of x looks like downward sloping, then 0, and then positive sloping. So 1, f of 1 is going to be a local minimum. Okay, so at 4 here, the derivative goes from positive to positive. So that means the function looks like positive, 0 slope, positive slope. So 4, f of 4 is a horizontal point of inflection. Okay, I hope you found this video useful.